Look at that. That is so cool. Wait a minute, can I step outside? Can you still hear me now? Yeah? Okay, cool. Because I actually don't like a mic like this. I want to walk around a bit, so I'll do something like this during my presentation. I'm PPK, I run Quarks mode, I test browsers so you don't have to. I test 50 mobile browsers. I've been testing them for 3 years now, especially in order to get a sense for what the mobile web is about. And as far as I can tell right now, mobile web development is pretty much like desktop web development, except for 3 things. The first thing is that there's many more mobile browsers than desktop browsers, and especially on Android the situation is very complicated. I'm not going to go into that. I treated that yesterday during my workshop. The second point is touch events and Microsoft pointer events, which are kind of like the mouse events but not quite. I'm not going to go into that either. I did during my workshop yesterday. And the third point is viewports, and that is what I'm going to talk about today. What is a viewport? Why would you care? And secretly, my reason for being here is to explain to you why responsive design works. Not how, you already know how responsive design works, but why does it work? If you add all those meta viewports and all those media queries, what are you actually doing? It took me 3 years to figure it out. Now I know, and I've condensed it into a 40-minute presentation. So after these 40 minutes, you will also know exactly what I am doing. This all may sound complicated, but remember one thing, you already intuitively know what to do. You are already doing it right. This is just background information. So, before we talk about the actual viewports, we have to talk a little bit about pixels, because there's 2 kinds of pixels, and they are not the same. There's CSS pixels and device pixels, and this may sound complicated, but you already know what they are. You may just not realize that you know. Because a CSS pixel is, as the name suggests, the sort of pixels that you use in your CSS. If you say width equals 190 pixels, padding left 20 pixels, font size 16 pixels, whatever, you are already using CSS pixels. And you should see them as an abstract construct layer that's built on top of the actual device screen, and that's meant to make your life easier. Especially when it comes to zooming, because the trick of CSS pixels that we'll refer to later in this presentation is that their size increases or decreases as the user zooms. Now on desktop, zoom is not so very important. On mobile it's hugely important because people zoom all the time. Let's take this site. This will be our example site throughout this presentation. It's a site for a conference I gave back in 2012. It was created by Stephen Hay. And since this conference was about mobile web development, it was, of course, properly responsive. However, for most of the presentation, we're going to presume that it's not responsive at all, and that it's just a desktop website, because you need to go through the same route as the mobile browser vendors did in order to understand why they did what they did. So, this website has a menu, right? Here on the left, and that menu is 190 pixels wide. And that's simply a fixed CSS width with 190 pixels. Nothing special there. Now, the user is going to zoom in, and what happens next? This happens. The menu is now larger. In other words, it covers more of the screen. Still, it's still 190 pixels wide. Any JavaScript test you can think of will return that that element is in fact 190 pixels wide. What has happened? Very simple. All the individual CSS pixels have stretched up because the user zoomed. So these 190 pixels now take more space, but it's still 190 CSS pixels wide. So that's CSS pixels. Device pixels are even simpler. They are the physical pixels on your device. Every single device out there has a screen, and that screen has a fixed number of hardware pixels. The number was decided on during the design of the device, and it cannot be changed in any way. So the best known example of device pixels is the iPhone. The old iPhone, the 3G, had 320 device pixels, and then along came the retina screen, which doubled that number to 640. Why? Because more device pixels gives you crisper and smoother images and fonts. and everything will just look nicer. However, what I'm thinking is that there's an upper limit to the number of device pixels that the human eye needs. Right now there's a kind of an arms race going on because every device vendor wants to have more device pixels on its screen because they think that more equals better. I think more equals better only up to a certain point, but I don't know which point. That is something we're going to figure out in the next few years. But anyway, these are not important. Here's a little schematic. On an old monitor, one CSS pixel exactly equaled one device pixel, right? Back in the day when we were very happy because we got a bigger monitor and we could now see sites in 1024 by 768, that was because one CSS pixel was exactly the same as one device pixel, so we needed more device pixels in order to show more CSS pixels. That has changed now. This can still be the case, but it's much more complicated now because basically because the user can zoom. For instance, here we have either a retina screen or a case on an older screen where the user has zoomed in to 200%. And you will see now that a CSS pixel overlaps 4 device pixels, 2 by 2. This is the basics of a retina screen. One CSS pixel now has several device pixels to display whatever is in the pixel, which means that more subtle gradients can be shown now. So what kind of pixels do you use in practice during your work? CSS pixels. Almost everything in both CSS and JavaScript works with CSS pixels. There's only one single exception to that rule as far as I know, and that's screen.width and screen.height. And screen.width and screen.height are a very serious problem that we're going to return to later. Okay, with all that said, we can go on to the viewports. What is a viewport and why would you care? We go back to our example site. This site has a container div that contains the main content, and that container div has a padding left of 34%. That's how Stephen Hay designed it. Now I'm going to teach you a little trick. As soon as you see percentages anywhere in your CSS, always ask yourself, percentages of what? Because usually the answer will give you a better insight in how CSS works. So we're going to ask that. 34% of what do we mean here? Now, intuitively, we all know the answer. It's 34% of the browser window, right? If the browser window becomes narrower, the 34% padding left also becomes narrower. But why is that the case? First, a general CSS rule. If you're using percentages in widths or paddings or stuff like that, it's always calculated relative to the container of the element, right? To the parent of the element. In this case, that parent is the body, because the container div is a direct child of the body. So what we mean here is 34% of the width of the body, which raises the question, what's the width of the body? That's 100%. This, again, is a general CSS rule that every block level element in CSS takes, by default, takes 100% of the width of its parent element. So, no surprises here. So, the body has an implicit width of 100%, and that is calculated relative to its parent element, the HTML element. And the HTML element, again, has a width of 100%, because that's the default. And now we come to the point. I mean, the HTML element is the topmost element in both your CSS and your JavaScript, and you cannot access anything that's above the HTML element, right? That's where it all starts. So 100% of what? And here we come to the viewport. We need something somewhere that constrains our CSS layout. We need something somewhere that says, okay, your CSS layout ideally should be this wide. And that is the function of the viewport. In the CSS specification, it's called the initial containing block, and it has exactly this function. And on the desktop, the viewport and the initial containing block are equal to the width and height of the browser window. And that is why that 34% you saw just now is relative to the browser window. On mobile, it's a lot more complicated. First of all, a little word more about desktop. When you zoom in, you enlarge your CSS pixels, and that means that less of them fit in the browser screen, which means that the viewport becomes smaller. This is something you have to realize. So here, excuse me, here we have, again, our example site. It has a viewport of about 720 pixels. That's because of the way I took this screenshot. There's nothing fundamental about 720 pixels. So now we're going to zoom in again, and the viewport changes to about 580 pixels because the individual CSS pixels stretch up and less of them fit in the browser window. This is how zooming works on desktop. But what happens on mobile? Before I answer that question, I'd like to put you in the mind of a mobile browser vendor back, say, in 2007, 2008. When the mobile web was still something new, Apple had just released the iPhone, Google was working on Android, Nokia and BlackBerry understood that they had to do something with browsers. And the problem was that on the one hand, smartphone consumers expected a smartphone browser to show any website. On the other hand, almost all websites back then were not mobile optimized in any way. They were just desktop websites, and the web developer assumed that they had at least 1024 pixels to play around with, which is of course not the case on a mobile screen. So if the mobile browser vendors would literally copy the desktop definition of a viewport, many sites would be squeezed to death. I'll show you now. This is the site on desktop. And now we're going to switch to the mobile view, and we're going to pretend that the mobile browser does exactly the same as the desktop browser. And you get this. And this is not what we want. This is the thing that mobile browser vendors wanted to avoid. Because the viewport is now, in this case, 342 pixels wide, but that's just way too little. And everything's messed up. So this is not the way they wanted to show desktop optimized sites on their mobile browser. So something had to be done. And that's why they changed the rules around viewports. They said that by default, the viewport should be between 768 and 1024 pixels wide. And the most common value nowadays is 980, because that's the iPhone value and many other browsers have copied it. So we make the viewport a lot wider than the screen, which means that we have enough space for our CSS layout. And this is what we call the layout viewport. And of the three mobile viewports I'm going to talk about today, it's by far the most important one. So again, the layout viewport serves to constrain your CSS layout, to tell your CSS layout, okay, this is the maximum width you can take. And responsive design is nothing more than the art of overriding this default width of the layout viewport. Because this is now the layout viewport, and the site renders pretty decently, but it's way too wide for the mobile screen. That's the problem that responsive design is solving. But the point here is that this decision to make the layout viewport much wider than the screen is a deliberate one, or else you could not show desktop websites on a mobile browser. However, since the layout viewport is now much wider than the mobile screen, and since we still need to know in some circumstances what the user is actually seeing right now, we need a separate viewport for the actual window width. And that's called the visual viewport. And that's this one. The visual viewport is far less important than the layout one. You will rarely need it in your code. It's mostly there for CSS declarations like position fixed. Position fixed should work relative to the visual viewport and not to the layout viewport. Because if you have a fixed element here, you want it to stay there regardless of how the user zooms or pans. And that's the main function of the visual viewport right now. Okay, can we read this out in JavaScript? Yes, we can. The layout viewport is in document element client width and client height. And this works in just about every single browser I tested. And remember, I tested 50 of them. The visual viewport is in window inner width and window inner height. And it's slightly less well supported. And the big pain point here is Android WebKit 2, which is the browser for the old Android 2 devices. It does not support window inner width and window inner height. Neither does Opera Mini, Opera's proxy browser. And neither does UC8. You know about UC, right? Who knows about UC here? It's the most important browser in China. So if you are targeting the Chinese market in any way, you have to keep track of the UC browser. Now, UC8 is a totally weird browser that I advise you to ignore completely. UC9 is a lot better. But never mind that. Be aware that reading out the visual viewport is possible in most, but not all browsers. So, we have the desktop viewport. And the desktop viewport served two purposes. First of all, for constraining your CSS layout. And secondly, for denoting how much of your site the user is currently seeing. And on mobile, these two functions have been split apart into the layout and the visual viewport. That's the story so far. However, on mobile, there's a third viewport. And it has no equivalent on the desktop. It's a completely new mobile invention, and I call it the ideal viewport. Consider. This is how most mobile browsers actually show a desktop website. The layout viewport is generally wide enough to contain the entire layout, so it looks kind of okay, but it's zoomed out all the way. A decision has to be made here because the site just doesn't fit into the mobile screen. So we have two options, either this or showing only part of the site. And zooming out is the preferable option because although you cannot read anything, the text is far too small, you can at least get an overview of the entire site and decide where you want to zoom in. On the main text, on the navigation, on the speaker photos, on whatever. So this is a trade-off. It's not brilliant, but it's the best we can do. What mobile browser vendors want, however, is for you web developers to use a viewport, a size of the layout viewport that's perfectly suited to the device. And that is where the ideal viewport comes in. Mobile browser vendors want their users to see a perfect site so that they don't have to zoom and pan immediately upon seeing them. They can just start reading. And the ideal viewport defines the ideal size of the layout viewport for the device it's on. So the layout viewport constrains your CSS layout, and there is an ideal value for that on the specific browser, on the specific device you're on, and that's called the ideal viewport. And it's essentially a value for the width and the height, somewhere buried deep inside the browser that you can call forth if you use the correct code. And once you do, you get a proper responsive design. Using the ideal viewport alone is not enough. You also have to use media queries to figure out what the actual size of the viewport now becomes and adjust your CSS. You know, 2 columns instead of 1, whatever. But then you get a proper mobile site. During this presentation, I have been using the BlackBerry Z10 as an example device. That has two reasons. The first reason is that I want to impress on you that there's more than just iPhone or Android. So you should occasionally test in BlackBerry or Windows Phone or even rarer devices. And the second is that it has a fairly weird ideal viewport, 342 by 570. You are probably thinking about the iPhone. The old iPhone had 320 by 480. The newer one has 320 by, I think, 568. Many other devices copied those values. The BlackBerry Z10 did not. It kept to its own values of 342 by 570. And the point I want to make here is that there are no wrong dimensions for the ideal viewport. I tested this again on 50 browsers from 35 devices, and I found not a single instance where the ideal viewport was clearly wrong. You know, you can quibble about 10 or 20 pixels, okay, but that's about it. The ideal viewport is also always exactly what it needs to be for the device it runs on. And I admit the BlackBerry values are weird, but they're not wrong. Okay, the ideal viewport serves a second purpose. Let's take a look at the iPhone in order to understand. The old iPhone had 320 device pixels, and the ideal viewport is also 320 pixels, and that's of course not a coincidence. Then along came the retina screens, where the number of device pixels was doubled to 640, but the ideal viewport stayed at 320. Why is that? Two reasons. First of all, the 320 ideal viewport is actually the best size for a website on an iPhone, given the physical limitations of the device. And secondly, if they would suddenly change this, a lot of sites would break. Because by the time the iPhone 4S came out, there were a lot of sites that already used the ideal viewport, and they had gotten used to the 320 value. So if it would suddenly become 640, you would have breakage all across the web, and Apple did not want that. Yes, there's a question.
When you say ideal, do you mean the ideal
The ideal viewport is the ideal measurement of the layout viewport for the device it runs on.
So the renderer thinks that the browser window is 320 pixels?
It's complicated because in the past, the ideal viewport was usually equal to the number of device pixels, but with the advent of the retina screens, it's not anymore. It's more like they go onto the device and look at a lot of websites, and then they decide, okay, this should be about this wide for perfect viewing on our device. So it's essentially an arbitrary number. I will partly get back to this later in my presentation. In any case, what the ideal viewport does here is serve as a kind of an abstraction layer, once more. You do not have to worry about the differences between the various iPhones, between the hardware, right? If you use the proper code, your website will look fine on all of them. That's even more important on Android, where there's a lot of different devices and a lot of different screen sizes. But in general, I found that the ideal viewport on Android is one of three values: 320, 360, or 400. If you make sure that your website works fine on 320, 360, and 400, you have covered 80 to 90% of the Android market. So this is a very useful abstraction layer for you. Right. Can we read out the ideal viewport in JavaScript? Not really. Now we come to screen.width and screen.height. And they are totally unreliable because it turns out that some browsers, newer browsers especially, define them as the dimensions of the ideal viewport, but other browsers define them as the number of device pixels on the screen. And you don't know what you're going to get, which means that in practice, you cannot read out what the ideal viewport is on a certain browser, except by actually setting it, which we'll return to later. Incidentally, this also means that all your nice analytics scripts that gives you percentages of resolution sizes are incorrect, because they all use screen.width and screen.height, but you don't know in advance if you're going to get the ideal viewport size or the screen size in device pixels. So do not trust your analytics package when it comes to mobile resolutions. It's likely to be wrong. Fun, isn't it? By the way, this is by far the worst browser incompatibility we're going to encounter here. The rest is just minor stuff, but this is a really serious one. I expect this definition, the first one, the ideal viewport one, to eventually win out, but the problem is that Android WebKit, the old default browser for Android, uses the other definition. Android WebKit is not maintained anymore, so we actually have to wait for the death of Android WebKit before we can switch over to this definition. Okay, so we have an ideal viewport, and what we want to do is set the layout viewport to the ideal viewport, so that our CSS layout is constrained to what the device vendor thinks is the ideal size for its device. And that's the job of the meta viewport. And I'm kind of assuming that this does not come as a huge surprise to you. So again, what you do when you use the meta viewport is setting the size of the layout viewport to the ideal viewport. What the actual size of the ideal viewport is, you don't know yet, because it may be 320, 360, 400, 768, 342, 1024, whatever. But you are now certain that your layout, that your CSS layout will fit the device perfectly. Of course, now you have to use media queries later on to figure out what the exact width of the viewport is. We'll get back to that later. So, by default, the layout viewport is between 768 and 1024 wide. That's for desktop sites that are not mobile optimized in any way. And using the meta viewport tag, you can set the width of the layout viewport to a value of your choice. You may, for instance, use a pixel value, such as 400. But in practice, almost everybody uses the device width keyword, which sets it to the ideal viewport. But again, this is totally allowed. I just haven't seen many practical use cases of it. But it works in all browsers. So, this is, I hope, not a total surprise to you, but I'm hoping that the next code example will be a surprise to you, because it turns out that there's a second way of doing exactly the same. And that's setting initial scale to 1. Now what we're saying here in theory, in Apple speak, scale means zoom. And 1 means 100%. So what we're saying here is set the initial zoom level to 100%. The question is, of course, 100% of what? Anyone, any ideas? The device width. The device pixels? Hardware width, you mean? Yeah. Excuse me? Of the CSS width? Now, it turns out that is 100% of the ideal viewport. Whether you actually use that ideal viewport or not. And that's weird. I did not expect this. But it gets even weirder. Because when you use initial scale, you also set the layout viewport dimensions to the ideal viewport. Just like width equals device width does. This code is exactly the same as the previous code example. I don't know why. I do not understand why. It gets even weirder when you change the value. When you set it to initial scale equals 2, that should of course mean that the browser should zoom in to 200%, which means that the CSS pixels grow larger, which means that less of them fit on the site. On an iPhone, this would mean that instead of 320 pixels, you now see only 160 pixels, right? But the layout viewport is also set to 160 pixels. Do not ask me why, I don't know. But it works like that in most browsers. Again, Android WebKit, the old Android default browser, does not do this. It does accept the value 1, but not any of the other values. Have fun. It's weird, and don't know why. But I can absolutely assure you that this works. Now we come to the fun part. Because the fun part of doing browser compatibility research is messing things up. I have now found out that there are certain rules that browsers obey. Let's give them conflicting orders. Let's do this. What we're saying here is first set the layout viewport to do 400 pixels, please. And then, no, wait a minute, set it to the ideal viewport width after all. What do browsers do? When I wrote this test and did the first test, I expected browsers to be absolutely all over the place and this to be a complete browser incompatibility mess. It turns out that that's not the case. It turns out that all browsers do exactly the same. They use the highest value. So they calculate the width of the ideal viewport, they compare it to 400, and they take whatever is the highest value. And the really fun part is that they recalculate that when the device orientation changes. So again, on an old iPhone, 320 by 480, right? In portrait mode, it's now 320 or 400, whichever is the highest, 400. And in landscape, it's 400 or 480. In other words, 480. So in other words, what we have found here is a way of setting a minimum width for the layout viewport. It now has a minimum width of 400. It may grow larger than that if the device says that its ideal viewport is larger, but it may not grow smaller. Ever since I discovered this back in October or November, I wondered, is there a practical use case for this? Because it's kind of fun to know, but can we actually use it? I haven't found any so far. If you can think of a practical use case for this minimum width, please come see me after my presentation because I'd love to hear about it. Okay, a Safari problem. Width equals device width. Stubbornly always sets the portrait width. Again, this is something that only Safari does. All other browsers use the portrait width in portrait and the landscape width in landscape. Safari does not. It uses the portrait width in both. 320 on the iPhone, 768 on the iPad. And sometimes that's what you want, and sometimes it's not. So, can we solve this? Actually, yes, we can. Initial scale equals 1. 320, 480 on the iPhone. And the problem is solved. Again, don't ask me why, but this works. And all other browsers do the same, so that's cool, except for A10, which has exactly the opposite bug. Now it does it wrong, and with the previous example, it does it right. It's such fun, isn't it, browser compatibility research? And I mean, you can't make this up. right? Nobody would believe you. So, sorry, what's your question?
What if you said both?
Exactly. You are completely right. You said both, and both bugs are solved. Because initial scale works properly in Safari, device width works properly in IE10, both work anyway in all other browsers. So this is the perfect meta viewport. Width equals device width, comma, initial scale equals 1. This is what you have to use. If you don't yet, please use this. Okay, now for one more complication. Back when the meta viewport tag was created by Apple, Opera said, yeah, it's all kind of cool, but it also doesn't make sense, because what we're doing now is giving instructions to the CSS in the HTML. So we propose a different syntax for the viewport. They implemented this in the old Opera that still used the Presto rendering engine. It has not survived Opera's migration to Blink, although I am told that Opera is trying to implement this in Blink. In any case, the only actual browser it works in right now is IE, and it's prefixed. But actually, it's pretty useful. The whole story of Add Viewport also gives you an idea of how browser makers react to what we web developers do. The point is as follows. On IE, this gives you the true ideal viewport. And what do I mean by the true ideal viewport? It turns out that if you use the meta viewport tag, IE 10 and 11 on a Windows phone will always give you 320. Why? Because iPhone. Right? They want to copy the iPhone because we web developers don't think enough about other devices. We just say, okay, 320 is the absolutely ideal size, and I mean, that has been a commandment from above, and we don't think about anything else. Which forces other browser vendors who really would like to use a different value to also use 320. So that's what the IE team said. If you use the tag, the meta viewport tag that we saw earlier, then you become 320, then the ideal viewport is 320. But if you use add viewport, you get the true ideal viewport. And I tested this on the Nokia Lumia 820 that I happen to have with me. And true ideal viewport is 364, which again is a weird number, but it's not wrong. And it actually makes sense because the Lumia 820 is slightly wider than the iPhone. So its ideal viewport should be slightly wider than the iPhone's ideal viewport. So, and also I have been told, but I have not yet tested, that the add viewport overrides the tag. So we have an even perfecter meta viewport. And that's this. If you also want to serve your IE users, add this to your CSS and this to your HTML, and IE2 will get the true ideal viewport. Okay. So what we have done now is set the layout viewport width, which constrains the layout of your CSS, to the ideal value that makes most sense on the device. We're not ready yet. We have now have to read out that actual value and adjust our CSS to it. Decide if we want 1 column or 2 column layout, if we want bigger text or smaller text, whatever. And that's the job of media queries. I'm kind of assuming you've all seen a media query, right? This is a media query. If the width is 600 pixels or smaller, this CSS is executed. But which width do we mean here? There are 2 important media queries in this respect. They are width and device width. And width is the one you want. If you're using the media query device width, I'm sorry to inform you that you are doing it wrong. Why is that? On desktop, device width gives you the width of the device screen. Do you care about that? No, not in the slightest. You are not interested. What you want to know is how wide the browser window is, right? And device width does not give you that. On mobile, it also gives you the size of the window, and it may seem at first sight that this is the information what we're after. Turns out that it's not, at least not in all browsers. Because what I discovered is that the device width and device height media queries are always equal to screen.width and screen.height in all browsers. And as we've already seen, screen.width and screen.height have 2 competing definitions. So if you use the device with media query, it will work right on Safari, which uses this definition. It will work right on Chrome, but it will work wrong on Android WebKit, the old Android default browser, which uses the other definition. And that's not what you want. So please do not use the device with media query. It's not suited to the job. Instead, what we want to know is the width of the layout viewport. And that is exactly what the with media query gives us. On desktop, it's the width of the browser screen, which is what we want to know. And on mobile, it's the width of the layout viewport, which is also what we want to know. Right here, we haven't applied the meta viewport yet, but if we do, we will get a properly responsive site. And it works always and everywhere in every single browser I tested. So it's completely safe. And once you do, you finally get a proper responsive site. You set the layout viewport to the ideal viewport, which gives you the ideal dimensions for the site. Then you read out what that ideal viewport width actually is by using the with media query and not device width. So that basically is why responsive design works. You already knew this, you probably already used this code, but I hope I taught you why it works and not just how it works. Oh, one more thing about media queries. Always use min or max. Never just use width. Because a breakpoint is these styles are valid for all widths that are lower than x or that are higher than x. And exact widths just don't work. A lot of people use the exact width 320 because iPhone, that is wrong. You can say max width 320, there's nothing wrong with that. But width 320 is wrong. There's more than just the iPhone. So that's responsive design. A second thing that people sometimes expect from responsive design is that it can make your page layout respond to the physical width of the device. For instance, it would be useful to set a minimum width of 25 millimeters or 40 millimeters or whatever you want on your navigation buttons, so that the user can always use them regardless of how much he's zoomed in or zoomed out. I am here to tell you that that is impossible. There is no connection whatsoever to CSS and JavaScript and the physical device. You just cannot find out anything about the device. And in order to understand why, we have to take a brief look at CSS units. With 25 millimeters does not mean 25 real life millimeters. Instead, it means exactly 94.488 pixels, which is usually rounded to 95, or maybe 94, depending on the browser. In a sense, centimeters, millimeters, and inches are fake units, because there is no relation whatsoever to real world centimeters, millimeters, and inches. Yes?
94 CSS pixels?
Excuse me?
94 CSS or device
CSS.
pixels?
CSS pixels. Because 1 inch in all browsers is defined as 96 pixels. If you create two elements, one has a width of 96 pixels and the other has a width of 1 inch, they will always stay the same, even if you zoom and your CSS pixels become larger. If you zoom in, your inch also becomes larger, which means that there is absolutely no connection whatsoever to the true physical world and CSS units. These are the definitions. You can look them up later in my slides or on my site. It's all there. I tested all this again in all browsers. It works everywhere exactly like this. Now, I used to think that it was a pity. I used to think that it would be pretty cool to have your site respond to real-world widths too, but I changed my mind. And that is because of, if an element would have true 25 millimeter width or min width, that would mean that every time the user zooms in or out, the browser has to recalculate the width of the element, because it may now be larger or smaller than 25 real world millimeters. And that eats way too much battery life, processor time, and memory. In general, mobile browsers tend not to repaint their page too much, only if it's absolutely necessary, because it's just an expensive job on a tiny mobile device. Right? On a desktop, we don't care. Our desktop has plenty of power and we can do all that we want, but a mobile device does not. And the key here is, of course, battery life, because it takes a little bit of energy to run all those calculations. And the more energy you take, the less battery life you get. So I think that the fact that CSS units have nothing to do with the real world will continue to exist forever. Final hope, maybe in some of your minds, that resolution will help you. No, it does not. Because resolution doesn't mean what you think it means. If you see more... Yes, there's a question.
How do M's and Rams?
M's and Rams. An M is always exactly equal to the font size in pixels of the element. So if you have a 12 pixel font size, an M is 12 pixels wide. If you have a 16 pixel font size, an M is 16 pixels wide. The rem does the same, except only with the root element font size. In other words, the font size of the HTML element, which by default is 16 pixels in most browsers. It's not going to help you here. And nothing is going to help you here. You are on your own. You have chosen the wrong career path somewhere in your past. I'm now going to tell you why resolution doesn't work. I love telling people why stuff doesn't work. Okay, we have this, right? And this all works in the browsers. Window.device pixel ratio gives you the device pixel ratio of the device. And if you want to do it in CSS with media queries, you can. You just need 2 of them, because min device pixel ratio works only in the WebKit-based browsers, and min resolution works only in the other browsers, with Chrome supporting both. But you need both these media queries. There's nothing complicated about this. This just works. But what exactly does it do? What exactly is device pixel ratio? It turns out, and this surprised me, that the device pixel ratio is the ratio between the screen size in device pixels and the ideal viewport size. Again, in all browsers. So you have the physical pixels on your screen, a lot, and you have the ideal viewport size, which is somewhat less, the perfect width of viewing a mobile site on your device. And the ratio between those two is what device pixel ratio is. So, as an example, the iPhone 3G, the old one, had 320 device pixels, 320 ideal viewport, device pixel ratio equals 1. The new iPhone with retina screen had 640 device pixels, 320 ideal viewports, because it wasn't changed. So device pixel ratio equals 2. The Samsung Galaxy Pocket is a pretty crappy little old Android phone that I have in my possession. And if you're doing serious mobile work, I advise you to buy a little crappy old Android phone running Android 2, because some of your users actually use such phones, and your website should perform at least decently in it. Okay, because it's so little and crappy, it has only 240 device pixels, but the ideal viewport of the default browser is still 320, because iPhone, which gives us a device pixel ratio of 0.75. Incidentally, I also test the old Opera Classic on this same device, and it has an ideal viewport of 240, and thus a device pixel ratio of 1. This depends on the browser. I think actually that Opera is right here. The screen is pretty small, and 240 makes much more sense than 320. But of course they wanted to emulate the iPhone, because we web developers are always talking about the iPhone, never about anything else. It's our fault, not their, okay? Finally, the BlackBerry Z10 that we saw earlier, 768 device pixels, 342 ideal viewport, which gives us this device pixel ratio. This is weird, but it's not wrong. No, you can laugh, but it's not wrong. You have to be serious about this stuff. It's just a mathematical equation, right? They decided that they wanted 768 pixels in their screen. They decided that their visual viewport should be 342, which kind of makes sense on the device. So this is device pixel ratio. Again, use min or max here, right? Never say device pixel ratio exactly equals 2. but say larger or smaller than 2. Incidentally, I ran a survey on my site back 9 months ago or something, and one of the results that surprised me is that when web developers use device pixel ratio, they check for a value of 1.5 or lower, and not 2. At least many did. And I think that actually kind of makes sense, because it includes many more browsers that don't quite have a device pixel ratio of 2. So you may consider using the value 1.5. We're nearing the end of my presentation. I give more information in an upcoming book by me, published by Smashing Magazine. I'm currently writing the last version of that, so it will take a little while more before it's ready. You are all required to buy it because I need the money badly. It ships in late June. And other than that, I think we have reached the end of my presentation. Thank you. The slides are, in fact, already online here. You can look at them if you want to. We have a few minutes for questions. I think I can take 2 questions. Yes?
So, step back. If we use your current viewport settings, what should we be using to size our divs, size our content?
Percentages. I would say so, yes. I mean, the percentage is always calculated relative to the layout viewport. So if it's 320, with 100% gives you 320. If it's 342, it gives you... Excuse me?
If we use those settings and we use percentage on our outermost div, or then it'll always fit the screen.
Yeah, then it fits the screen perfectly, yes.
I actually want to chime in right here. Do not use half or quarters or anything with percentages, because a lot of browsers found that so if you use like a perfectly 33.3%, it doesn't work.
No, it has to round to a certain number of CSS pixels, which then again is rounded to a certain number of device pixels. If the CSS pixels have a different size than device pixels, then in the end, the device must say, okay, I make so many device pixels yellow, right? That's my div. So the calculation is, if you use percentages, you first take the layout viewport, you calculate the percentage of that. That gives you the CSS pixels. Then you have to compare that, of course, to the zoom factor, etc., etc. The browser does all that. You don't have to. And then it's converted to a number of device pixels. So the actual results may indeed slightly differ. But in most cases, I would argue that it doesn't matter all that much. Especially on a very high density device, your clients are not going to notice that it's 2 device pixels less than on the other device, I would say. Any more questions? Nobody? Okay, thank you for your attention.